Okay, so now vapor pressure, which will sound like everything that we've kind of talked about already. And that's great because it's related to everything that we've talked about already. The difference for vapor pressure is that we are imagining that this liquid that we have, it's in some kind of closed container where it can get into a dynamic equilibrium with the gaseous form. So the pressure of a gas in dynamic equilibrium with its liquid form, that is the vapor pressure. Vapor pressure increases as intermolecular force strength decreases. And right, this is related to how easy it is to pull those molecules apart. So vapor pressure and boiling point should have the same kind of trend. Um, and vapor pressure and boiling point are directly related to each other. As the temperature goes up, the vapor pressure goes up until you reach the boiling point. So you probably have in your mind um, like a picture of what boiling point means. What the official definition for boiling point is, it's the temperature at which a liquid's vapor pressure is equal to the external pressure. So the external pressure has an effect on the boiling point of any liquid. We call it the normal boiling point when the pressure is 1 atmosphere. So when the external pressure is 1 atmosphere, then it is considered to be a normal boiling point. So it's like our standard pressure conditions of 1 atmosphere. Because of this, depending on where you are, depending on what your elevation is, because the external pressure changes with elevation on the planet, um, water can have very different boiling points. And this is sometimes you will see this printed on as the instructions for like baking or maybe for like boiling pasta, where it will give you a different set of instructions if you're at if you're at different elevations. So if you're in Boston, which is at sea level, St. Louis is kind of at slash below sea level. Boiling point of water is 100 degrees. If you're in Denver, which is 5,280 feet, the external pressure is lower. So the boiling point is 94 degrees Celsius in Denver. If you're in Mount Everest, the external pressure is so low that the boiling point of water is 78 degrees Celsius. So, direct relationship between external pressure and the boiling point. So, we have an equation that will let you calculate what the boiling point is, or really what the vapor pressure is at an external pressure. And this relates, we have two forms. We've seen an equation like this before where we have a single point form and a 2 point form. The single point form will be the more accurate, but the one that we're less likely to use. So the single point form is the natural log of pressure equal to negative enthalpy of vaporization over R times 1 over T plus it's like the natural log of beta is what this thing is. So this is the Clausius-Clapeyron equation. The slope of this would give you a straight line. This really is going to relate the external pressure. It would help you find the enthalpy of vaporization for a substance. That's like the practical case where you would use something like the single point form, right? Because pressure and temperature are in here and they're related through the enthalpy of vaporization. The intercept, we don't use that value. It would be a value characteristic of the substance that we're looking at. We just don't have kind of a practical use for it. In terms of Gen Chem, I'm sure someone does. For the 2 point form, we can relate a pressure and a temperature that are paired up to any other pressure and temperature that are paired up. That would fall along, right, the trend line that you get from the single point form. And there is like a handwriting typo. I don't know. I miswrote this equation a little bit. So just in the 2 point form, it should be the natural log of P2 over P1. And it is correct on the equation sheet, so definitely double check the equation sheet to make sure that you're using the correct version.